This airplane should not be able to fly. Its engine operates at temperatures hotter than the melting point of its own metal. It's designed to be so unstable, it's constantly trying to tear itself from the sky. And to an enemy radar, it appears no bigger than a bumblebee. You think you know the F-22 Raptor, but the headlines about speed and stealth don't tell the real story. The real story is a 30-year-old engineering miracle that is still unmatched. Today, we're not just looking at the Raptor. We are breaking down the untold engineering secrets of the F-22. The first and most famous secret of the F-22 is its stealth. But the term stealth is almost misleading. It doesn't have a cloaking device. It's a marvel of physics, shape, and materials designed to solve one problem. How do you make a 62-foot, 43,000-pound fighter jet have the radar signature of a steel marble? The first secret isn't in the material, but in the shape. It's a design philosophy called Planform alignment. Look closely. The leading edge of the wing is angled at exactly 42 degrees. Now, look at the trailing edge of the tail fins, also 42 degrees. The engine intakes, the tail planes, nearly every major edge on this aircraft is aligned on just a few common angles. The reason is simple, yet revolutionary. An aircraft with hundreds of different curves and angles scatters radar energy in every direction, guaranteeing some of it will bounce back to the enemy. By aligning its edges, the F-22 minimizes these angles. This is genius. Instead of scattering radar energy randomly, the F-22 controls it, reflecting it in a handful of very specific, narrow directions. These exact spots are predictable lobes of radar energy. As long as the F-22's flight path keeps the enemy out of these narrow zones, the aircraft simply doesn't return a detectable signal. It creates a cone of invisibility. But this created a manufacturing nightmare. The tolerances were insane. If a single panel was misaligned by more than a few thousandths of an inch, the width of a human hair, it could act like a beacon, compromising the entire aircraft. The skin of the F-22 isn't just a covering, it's a critical part of a precisely tuned system. But shaping the wings is the easy part. How do you hide a jet engine? The spinning fan blades of a turbine are a perfect radar reflector. They're metallic, complexly shaped, and their constant rotation is a dead giveaway to Doppler radar. This was one of the biggest challenges. A straight intake duct is like an open tunnel pointing right at the engine's reflective core. The solution is one of the Raptor's most elegant secrets, the serpentine duct, or S-Duct. The engine air intakes are not a straight line. They curve twice, creating a physical wall that completely blocks any line of sight to the engine face from the front. The walls of these ducts are also lined with top-secret radar-absorbent material, or RAM. Any stray radar energy that makes it inside is forced to bounce off these walls, and with each bounce, its energy is absorbed and converted into a tiny amount of heat. The signal never comes back out. Finally, there's the paint. But calling it paint is like calling a smartphone a rock. The F-22's coating is a complex, multi-layered system of radar-absorbent materials. These materials are made of ferrite particles suspended in a special polymer. At a microscopic level, when a radar wave hits the skin, it causes these particles to vibrate, converting the radar's electromagnetic energy into heat, further reducing any reflection. Even the canopy is a secret. It's infused with a thin layer of gold and indium tin oxide, which blocks radar waves from entering the cockpit and bouncing off the pilot's helmet and equipment, another potential source of reflection. When you combine the shape, the S-ducts, and the skin, you get a radar cross-section estimated to be just 0.0001 square meters. For comparison, the F-15's is over 25. The F-22 is, for all practical purposes, a ghost. But radar is only half the battle. A fighter jet is a flying furnace, a beacon to heat-seeking missiles. So how does the Raptor hide its own fire? The secret is a revolutionary thermal diet. The F-22's most powerful systems, its active electronically scanned array, AESA radar, the central brain computers, and the electronic warfare suite, generate incredible heat. To get rid of it, a specialized liquid coolant called polyalpha olefin, or PAO, circulates through these electronics, absorbing their intense thermal energy. But here's the genius part. Instead of venting this heat outside, the hot PAO is pumped through a fuel-cooled heat exchanger. Now, it's crucial to understand. The coolant and the fuel never actually mix. They flow through separate pipes that run alongside each other inside the exchanger. The heat simply transfers through the conductive metal walls, from the hot PAO coolant into the cold jet fuel. The result? The F-22's entire fuel load acts as a massive heat sink, silently absorbing the thermal energy of its own powerful systems before that fuel is ever burned by the engines. This eliminates the need for drag-inducing vents or scoops that would be a disaster for its stealth profile. Even the iconic engine nozzles serve a dual purpose. Their flattened, rectangular shape is designed to spread out the 3,000-degree exhaust and rapidly mix it with cold air, masking its heat from enemy eyes. It's not just invisible to radar, it's a ghost to infrared sensors too. Stealth gets you into the fight unseen. But a revolutionary engine and flight control system is what ensures you win it. The heart of the Raptor is another collection of engineering secrets. The twin Pratt & Whitney F-19 engines. Every fighter jet has an afterburner, a system that dumps raw fuel into the engine exhaust for a massive but temporary burst of speed. The problem? It consumes fuel at an astronomical rate and acts like a giant neon sign to heat-seeking missiles. The F-22's first engine secret is Supercruise. It can fly at over Mach 1.5 without using the afterburner. This was considered a holy grail of fighter design. It allows the Raptor to control the battle space, choosing when and where to fight, all while conserving fuel and remaining thermally stealthy. So how is it possible? The secret lies in advanced thermodynamics. The F-119 engine can generate 35,000 pounds of thrust per engine. It does this by having a higher pressure ratio and running at temperatures that would melt the engines of its predecessors. The turbine blades inside the engine are grown from a single crystal of a top-secret metallic superalloy, meaning they have no grain boundaries, the microscopic cracks that are the weak points in normal metal. This makes them incredibly strong at high temperatures, but even that's not enough. The blades themselves are hollow, and a constant stream of cooler air from the compressor is bled through a series of tiny laser-drilled holes. This creates a boundary layer of cool air over the blade's surface, insulating it from the superheated gases. It's an engine that operates at temperatures hotter than the melting point of its own components. That is the mind-bending secret to its power. But power is nothing without control, and the F-22's second engine secret gives it an agility that seems to defy physics: 2D thrust vectoring. These rectangular nozzles can move up and down by 20 degrees. This allows the pilot to literally point the engine's thrust. At high speeds, this gives it incredible turn performance. But at low speeds, where traditional control surfaces like ailerons and rudders become ineffective, the F-22 remains fully controllable. It can point its nose at an opponent even when it's barely moving forward, a feat known as post-stall maneuverability. It can effectively stop on a dime in midair, fire a missile, and fly away. But here's the untold part. A human cannot fly this plane alone. The F-22 is aerodynamically unstable by design. This instability is what makes it so agile, but it also means it is constantly trying to tear itself out of the sky. The real secret is a triple redundant, digital fly-by-wire flight control system. It makes thousands of micro-adjustments per second, but its genius is how it integrates everything. When a pilot rolls the stick, they aren't just moving the ailerons, they are giving a command to the jet's brain. The computer then orchestrates a symphony of movement, flaps, rudders, and thrust nozzles all working together to achieve the maneuver with an efficiency that is physically impossible for a human to replicate. The pilot is not so much flying the plane as giving his intent to a genius co-pilot made of silicon. Stealth and agility are useless if the pilot is blind. In an age of information overload, the F-22's greatest secret isn't what it shows the pilot, but what it doesn't. This is the quarterback's eye. Older jets, like the F-15, had a problem. Each sensor, the radar, the infrared search and track, the electronic warfare suite, had its own screen. The pilot had to look at 3 or 4 different displays, mentally fuse the information, and then make a decision in a split second. It was like trying to solve a puzzle while pulling 9 Gs. The F-22 was the first fighter to solve this with a concept called sensor fusion. It has one of the most advanced radar systems ever created, the AN/APG-77, which can see targets over 150 miles away. It has electronic surveillance systems that can listen to enemy emissions. It has a data link that allows a squadron of F-22s to share what they see, creating a god's eye view of the entire battle space. But the secret is that the pilot doesn't see any of this raw data. The F-22's central computer, the CIP, or Common Integrated Processor, acts as the jet's brain. It takes in hundreds of streams of data from every sensor, instantly verifies it, and fuses it all into a single, simple picture of the world. On the pilot's screen, an enemy plane isn't a radar blip. It's a single red triangle. A friendly is a green circle. A surface-to-air missile site is a blue square. The pilot doesn't have to interpret data. They just have to act. It transformed the pilot from a sensor operator into a true battlefield commander. This is what pilots mean when they say the F-22 gives them first look, first shot, first kill. They can see the enemy, target them, and fire a missile before the other pilot even knows they are there. But the F-22's radar is not just for seeing. It's a weapon in itself. This is its most classified secret. The AESA radar can focus a beam of microwave energy so powerful it can act like a surgical electronic warfare weapon. It can overwhelm enemy sensors, jamming their radar so they see nothing but static. More than that, it can physically degrade or even destroy enemy electronics. It's not just hiding from radar, it's actively hunting it. It's a ghost that can reach out and blind you. But this level of perfection came at a staggering price. The F-22 is the most expensive fighter jet ever built. The program cost over $67 billion, with each aircraft having a flyaway cost of over $150 million. The stealth coating, so critical to its survival, is also its Achilles heel. It requires an incredible amount of maintenance. It was said that for every hour the F-22 flew, it required over 30 hours of maintenance on the ground, much of it dedicated to ensuring the stealth skin was perfect. The original plan was to build over 750 Raptors, but with the Cold War over and costs soaring, the program was cut short. Only 187 were ever built. Today, the F-22 is a paradox. A fighter so advanced and so expensive that it is rarely used in combat, held back as a strategic asset. A silver bullet for a war America hopes it never has to fight. The secrets of the F-22, its shape, its skin, its fire-breathing heart, and its all-seeing eye, redefined what a fighter could be. It was a machine built for a level of perfection that the world had never seen, and may never see again. And if you enjoy digging into the nuts and bolts of how the world works, make sure you subscribe and hit that bell so you don't miss our next deep dive. Thanks for watching.